Welcome everyone to Physics Reimagined. Today we have Mr. Akash Roj and Professor Amrit Shorley with us to discuss a fascinating new perspective on gravity. Akash and Shorley, thank you so much for joining us.
Thank
So,
you, thank you.
so let's start this journey.
Thank you, Chris, for having us here. Well, this time we are ready for discussion about gravity. I respect Einstein's idea, because Einstein has great intellectual idea about gravity.
Yeah.
But his gravity of curvature, space time, this doesn't identify a real physical mechanism, because this is purely mathematics.
Yeah.
If we talk about it purely mathematics, then it does not define like what curves space. I mean, space cannot be curved. Let me see what Solisar says.
Yes, sir.
Uh, 100 years ago, general relativity was a good idea, but in 2014, NASA measured with high precision that universal space has Euclidean shape. And this actually means that general relativity is a mathematical description of some deeper properties of space, which actually is not curved,
Yeah.
but there is something else here. And in the past, yes,
Yeah, it's true actually. People should know about this because NASA already has conducted an experiment in 2014. They tried to measure, interstellar angles, and they found their, angle to be 180 degree, very close to 180 degrees. So
Yep.
people should know about it. So they will, start believing that space is not curved.
yeah, exactly. What our research group has done in the past years is that there are few elements in physics which are somehow well recognized,
Yeah.
and one of them is the Planck units.
Yes.
So we have a Planck mass, we have a Planck volume,
True.
and if we take a Planck mass and multiply by c squared, we will get Planck energy.
Yes.
And the Planck energy density is amount of energy in a volume of the Planck, and this is actually in the interstellar space.
This is the key point.
And where we have, let's say, where we have a physical object, imagine that this is Earth. This is our planet Earth.
Yeah.
The energy density of superfluid space is diminished in the center exactly for the amount of its mass. This is so-called extension of the mass energy equivalence principle on the space.
Yeah.
Because Einstein's idea that space is empty and deprived of physical properties, we see today that this idea was not the best one.
Because this time we can see, we talk about ether. So people this time renamed ether by saying quantum fluctuation, Higgs field, but this is actually ether. But this time in modern physics we call ether as quantum superfluid medium, and this is a dynamic medium which as the sir said this time, like an object in this space, it actively diminishes the energy. And you may ask, like, why does it do so? So it is simple. Whenever you think about Higgs field or any object, it needs certain energy for its existence. So it actively diminishes the energy, which creates gradient. And because of that gradient, space pushes the object, and we perceive it as gravity. but this is real this time. It is not curved. So we can, if we further think about it in detail, so we can answer each and every question about gravity. We will not have any anomaly and the things which will not be, be solved. Even we can solve this by our theory. Yeah.
Well, Mr. Saroj,
Yeah.
you mentioned ether.
Yeah.
Ether is a term. It is mentioned many times in old textbook,
Sure.
but it's my request
Yeah.
to explain ether some words to our audience because there are many people who do not have.
Yeah. As you know, I just take the concept as Sorley sir explained about
Yeah.
ether. He explained ether in a beautiful way by saying like Planck energy density. So I say ether is a quantum superfluid medium which carries Planck energy density with it,
Yeah.
and this is now ether. In the modern physics, we call it as quantum fluctuation, Higgs field, as I earlier mentioned. But this is ether this time.
Okay.
And one more thing I would like to add, because people may say like by taking ether in our universe, in our theory, if we already conducted an experiment as Michelson-Morley interferometer, but this idea has already rejected ether concept. But I would say they had wrong assumption in Michelson-Morley
Michelson-Morley
interferometer.
experiment, yeah.
That's why they did not ever detect ether. If I'm not wrong, let's me just see perception of Saudi sir.
Yes, sir.
If when we have a physical object, the physical object has attributes of energy, and this means that something or whatever has an attribute of energy cannot exist in a medium that has no these attributes of energy. So this means that actually space, the idea that space is deprived of energy, that's empty, this idea somehow is in the last 20 years is surpassed.
Yes.
And today we know that space is a type of energy. So for the, let's say 100 years ago, when Einstein built the general relativity, the idea was elegant, was something new, but today we see that we can improve it. So actually, the more space is curved in Einstein relativity, in the model that we develop, the less space is dense. So in the black holes, the density of space is at the minimum. And what happens in the black holes, this is well observed astrophysical jets. In the huge black holes in the center of galaxies, we call this active galactic nucleus, there are huge jets of energy coming out of these black holes. And the proposal that I did years ago is that in the center of the black hole, energy density of space is so low that the atoms become unstable.
Yeah.
Because when you have low energy density, this changes electromagnetic properties and the atoms become unstable. They fall into elementary particles. And these particles are this fresh energy that is thrown out of black holes, these supermassive black holes in the center of galaxies. So we see that through this view of gravity, actually the Big Bang theory belongs to the past.
I have a question, one more question to both of you. When we study about black hole, then we get to know about singularity.
Oh.
So how do
Yeah.
you define singularity? Because it's just a big term, such an interesting term whenever we study physics.
That's
Singularity is total bullshit idea, I think, because singularity should not be accepted. Yeah.
the curvature of space
Yeah.
actually led to the idea that when you have a very dense physical object, then there is a huge hole in the space-time. But these holes in the space-time actually they don't exist. There is no hole there. There is only a star which has extremely dense energy.
Yes.
So Penrose has somehow developed on the basis of general relativity, this idea that when space is extremely curved, that you have an infinite gravity. But no, there is no experimental evidence for infinite gravity in the center of black holes. And what is more, let's suppose that this is a black hole and that the gravity here inside is infinite. We know in mathematics that when we have one infinite point, let's say of gravity, when we go away from this point, the infinity cannot diminish.
True.
You know, only the finite value can diminish when you go from point T where it's infinite away. So actually, the gravitational singularities are opposing the fundamental mathematical and physical rules.
Yes, and you know one thing, like whenever people do not have any explanation for black hole physics, so they say that the physics does not follow the rule.
Yeah.
And this is totally I can say foolishness. But this time, I would like to add one thing. Like when we think about gravity and its existence, right? So it's simply whenever, as earlier we mentioned, that an object is actively diminishing the energy density of any space in its center. So it creates that gradient, and due to that gradient, space pushes. And in alternative way, we can say that it forms like a whirlpool space flow. But this time we can also say, if the space is pushing the object in toward that object as we perceive as gravity. So one may ask one thing, like what happens when that push or that flow will go away from the object? So I would say no. This is not symmetric. Like this is object and the space is flowing, and object is getting pushed toward that object, and further object will not go away because this flow is asymmetric. What will happen now? Let's me see by an example. Suppose this is a ball falling toward this object, falling toward the earth or whatever we call. So this ball is coming toward this part. Why is it so? Because space is filling gap which has been created due to gradient of energy density. So the object comes toward this part because of filling the gap. But
Because
this
of
time,
gravity.
but this time, what happens next? This is the main key. So this time, object accept that space energy and changes into another form of energy. As we release infrared radiations, we can see Hawking's radiation. As Sorley sir explained about astrophysical jets coming out from the black holes. So in this manner, we can simply define like how do we radiate energy, where does this energy come from. This is all space energy.
Okay. Well,
Nothing is lost in the universe.
Yes.
Nothing was created and nothing is lost. What is important regarding we have to finish this question. What is important in the gravity of black holes?
Yeah.
That in the black hole, when we go inside towards the center of the black hole, the gravity diminishes according to the Newton shell theory.
Yeah, Newton's theory. It is
Because a black hole is nothing, it's not different from the other stellar objects. The only difference is that it's extremely dense.
Yeah, it is.
So in the center of the black hole, the gravity is zero, as in the center of the moon, in the center of the earth, in the center of every stellar object. And this is a problem in physics that we have now for 100 years, that somehow mathematics has prevailed physics.
Yeah.
So if you have today a good mathematical model, nobody will ask you how much sense this model makes.
Yeah.
They will publish it.
True. true.
And let's say one example. Years ago, there was a published article about negative mass.
Okay.
So that the mass can be negative, and that this also means that the energy can be negative. I mean, all this is a very speculative approach. That's why in our institute we develop a bijective research methodology. What does it mean? In a theory, let's say theory of gravity, every element that you use in the theory must have some correspondent element in the physical reality. Let's say the famous formula of Newton. You have mass 1, mass 2, gravitational constant, and down you have r squared. So every element that we have in this equation, we know what does it mean in physical reality. In Einstein general relativity, this is a serious problem, because with the equations of the Einstein relativity, you cannot calculate the gravity force between Earth and the Moon. You can't calculate it. Still today, after 100 years, they still are not, they don't agree, physicists, which units has gravitational Einstein gravitational tensor. They don't agree. We know that force we measure in newtons, you know. So Einstein general relativity is highly speculative, mathematically speculative. And I believe with the introduction of superfluid space, which is a new name for ether, that relativity can become more compact, more physical, and actually,
Well,
I believe.
To you
Yeah.
and Professor. Well, we all are talking about Einstein's relativity.
Yes.
So it won't be cool if we don't talk about light.
Right.
So it's my question. When we study in higher classes, we get to know light is a energy, is a form of energy by which we can see the surroundings. Then we promote it to the higher secondary classes, class 11th, where we get to know the light have wave and particle nature. Then,
Yes.
in your views, how do you define light?
Yeah. Well.
I will start with Professor.
Yeah. Let's listen.
This particle wave duality. This is some very deep question of quantum physics. In the model that we develop, light is a wave
Yeah.
of superfluid space.
Yeah.
Because this superfluid space is four-dimensional.
4 dimensional.
This is a type of energy that has 4 dimensions. So the electric field is excitation of the superfluid space along x1, x2, x3, and magnetic field along x2, x3, x4. And the photon is a 4-dimensional wave of superfluid space. But when you mentioned before this particle or wave, there is a famous, we all know this is a very famous experiment of double slit experiment.
Yeah.
So when we send electrons only through the upper slit, we will have, let me finish, this is very important. We will have also the interference pattern as that the electrons also pass through the down slit. What is the case? The case is that the electrons, when they move through the upper slit, they also generate a wave of superfluid space, which is passing the down slit. So the wave and the particle are always together. This is the new insight of quantum physics. They are not two separate realities that electron once is behaving like particle and in some other experiment as a wave. Because every elementary particle moving through superfluid space will generate a wave.
Okay, so if I conclude everything, you both are just rebuilding the physics now.
Yeah, definitely. Physics needs some, better development this time. Pius, one thing, as we say that our theory, our model of gravity,
Yeah.
to be precise and to be correct. So, what people ask for? They ask for some mathematical equations,
Mathematical
mathematical
values, yeah.
term. Well, we also developed a mathematical equation which correctly defines everything. You know one thing, gravitational lensing, as Einstein
Yeah.
famous by Eddington experiment in
Mhm.
at that time. So when light passes by near any sun, it faces it passes through variable energy density, and due to this light bends near the sun, and
Okay.
we have developed its mathematical model also. And surprisingly, we got the same result as Einstein got, as Einstein general relativity has passed so many tests, you know. So I believe, or we believe, like we have also a mathematical model which gives the exactly identical result, but in different way. Now our theory and our model has more advanced mathematical model which can explain the entire, maybe entire thing of the universe, which is not being explained by general
But
relativity.
in short,
So,
you are saying that
yeah,
the values which have been calculated by the experiments,
yeah,
you calculated them without any experiment.
yeah. We
By
use
just making
simple.
equations.
Yeah, we use simple
That is
mathematics
such as
too.
amazing. Such an
Yeah. I would like to thanks to Sorry sir, because his blessings are always with us.
If I conclude everything,
Yeah.
then when we study,
Yeah,
when we used to study, when I was in 9th standard,
Yeah.
I got to know the gravitational force.
yeah,
All planets are revolving around the sun
Yeah,
because of
yeah,
gravitational
yeah.
force
Yeah.
that was discovered by the Newton.
definitely.
Then when I move further
Yeah,
in higher classes, I get to know the gravitational force, or that concept, universal law of gravitation,
Yeah.
was falsified by or rebuilt by general relativity.
yeah.
And
I
now
understand.
we have this theory which is recreating all the things.
Yeah, and surprisingly, this theory unifies every theory like quantum physics, nuclear physics. To be more precisely, say this is a unified theory.
You both guys are targeting Heisenberg, De Broglie's, Einstein.
We will not say we are targeting. We are just
You
extending.
both are on rampage.
Yeah, and one more thing you will be surprised by knowing ether's existence. Sorry, sir, will explain about Sagnac experiment and more things. Then you will get to know that ether exists in reality. So
Yeah, this about ether.
Yeah.
Actually, in the Newton physics, ether is indispensable element, and you will not believe that when I read original work of Newton, he didn't develop this in mathematical form, but he say it must be that every physical object diminishes density of ether, and that this generate gravity. I was so happy when I discovered this, because actually with this extension of the mass energy equivalence principle, we develop a mathematical formulation of Newton view on gravity. It's the gravity that we develop actually is development of the Newton gravity, and it shows that this theory has much more power than Einstein relativity.
yes.
Well, Professor, I have one question more to you, especially. When we study about spatial relativity of Einstein, then we get to know about mass variation, the time dilation, length contraction,
Yes.
the many things which is really too much difficult or complex to understand by the normal mind, if I say. So, what are your point
Yeah.
of view? What are your thoughts
About time.
on
You
on
know that-
time, on mass variation?
Yeah.
Yeah.
Special relativity, the special relativity was a kind of breakthrough, in 1905. But the mathematics that was used was actually a bit tricky, because the length contraction was invented by Lorentz to save the ether theory. Because when the Michelson-Morley experiment gave null result, the Henrik Lorentz, which was a great theorist about ether, he said we have to save the ether theory. So he invented the length contraction, and Einstein used this in special relativity, and we published several articles that special relativity can be described with Galilean transformation and Celeri transformation for time. Because what is the main insight of special relativity is not that time is relative. Time is not relative because there is no time in the physical universe. Relative is the rate of clocks.
Okay.
And let's say that you are on the moon and your twin is on the earth. You on the moon, you will age a bit faster. But you are both aging in the time invariant space. So actually, the advanced relativity is that we remove space from the model as something physical, time from the model as something physical. Time is only a tool of physics to describe velocity. But we have to say one thing more. The Michelson-Morley experiment gave negative result because the Earth, it's moving through the universal space, but it's also the local ether around the Earth. It's moving and rotating with the Earth. That's why the Michelson-Morley experiment gave a null result, because the proposition was that ether is stationary and that the Earth is moving to the stationary.
They had wrong assumption.
So that was the reason.
They had wrong assumption at that time. Yeah.
They got nil result.
Yeah, of course.
And they got Nobel Prize for this.
Let's just forget about this time Nobel Prize.
Let me tell you one thing more. This special relativity. You imagine we are in the spaceship and we have two photon clocks. One photon clock is pointed in the direction of the motion, and the other photon clock is pointed vertically. So because of the motion, the horizontal photon clock will have a length contraction effect and will run with a different rate than the other clock. In the special relativity, in a given inertial system, two clocks cannot have different rate. So the special relativity mathematical model is contradicting itself, this length contraction and space, time dilation. These are just mathematical tools to describe relative velocity of events, which actually which is real. But it was good. This is more than 100 years ago that this was built. It was good achievement, but we have to go on.
Yeah.
Yeah, this is the reality of this universe. Unless we ignore general relativity, we can't have success in physics this time. I think this time we need a real physics which explains about real gravity. Let me just say one thing also. You may ask, when two objects fall toward the earth, they fall at the same rate. How can we explain using our theory? It is very simple. You see whirlpool in ocean.
Yeah.
When the two objects are getting pulled by that whirlpool gradient, so their pulling rate is unaffected by their mass. In a simple way, when the two objects are falling from the space toward the earth, that push is unaffected by their mass, and this is how we defined why two objects fall at the same rate. And I will show some mathematics to you also. I will say to public people.
Well, do we have any idea to get to know what kind of nature the ether has and what speed does it have in universe?
Ether speed.
The ether speed.
This is actually the question which depends on the vibrational effect by the planet, how much energy it is diminishing.
Okay.
It also depends on that, and by what ratio and what speed does the object spins. So it varies.
Well.
Yeah.
I have one question more.
Yeah.
Because it's just a milestone, you can say.
Yeah.
When we talk about general relativity, then we can't forget the Mercury's perihelion.
Yeah.
So now let's discuss about this.
Madam,
Professor.
already Mercury precession. Yeah.
Precession.
Mercury precession. It's a great result, you know. But if you see the equation with which Einstein calculated Mercury precession, there is no curved space there. There is nothing there. It's just an ordinary geometry is there. So when they say that the Mercury precession is the result of the curved space, there is no proof for this. Actually, what happens that when we have a situation in the universe that the given solar system, a given sun, it's rotating around the axis, you know, the sun also rotates the local superfluid space. In physics, we call this space dragging effect.
Yeah.
But actually, what happens that sun is rotating this local space, and that's why the Mercury has a bit of precession.
Yeah.
The same is observed for 100 years that in the galaxies, some stars which are on the outer part of the galaxy, they have a bigger orbital velocity than they should have according to the Newton laws. This is because in the center of the spiral galaxies, there are huge black holes. And these black holes rotate the local superfluid space.
Yes, black hole.
So the stars have a velocity, orbital velocity is velocity according to Newton plus velocity of the local ether. And that's why now we see after 100 years so-called dark matter that was theoretically put in the physics to resolve this problem. They didn't find it until now, dark matter. You know? We published already a few things on this because the idea that this so-called ether is something stationary, not moving, you know, this idea was not the best one. They have been already 100 years ago idea that ether might be dynamic.
Yes.
And once we understand that the ether is a type of energy, then it's logical that if you run, you know, if the planet is running around, rotating around the axis, that this energy also will start moving around.
Yeah.
And this is so-called Sagnac effect. You know?
Yeah.
And when we calculate the rate of clocks on the satellites, we use also Sagnac correction.
Yes.
And Sagnac correction is because the local superfluid space is rotating around the Earth.
I have one question more to both of you.
Yeah.
When Einstein was making equations, he used Minkowski space.
Yeah.
So, what are your views on Minkowski space? How does it lie on the topic?
Well, if I talk about Minkowski space, whenever we need to explore something mathematically, then we use it. But we do not need to explain much about acceleration due to gravity as we perceive, velocity, and to be more precise, gravitational potential also. And even we derived our light bending equation. We did not use Minkowski space, but this is mathematical tool.
Just a mathematical.
Yeah, of course.
Well, did you both use?
No. But if we need, then we'll definitely use
just
it.
a mathematical tool. Okay.
Yeah.
Thank you so much.
It's very interesting question, this Minkowski, you know. You have it here, you have a cone, here you have a past, here you have a future, and here you have a present. I mean, for today understanding, this is a bit of kindergarten picture, you know. This is a bit of kindergarten understanding because 10 years ago, I introduced the model of time invariant space. Space-time, where time is a fourth dimension, belongs to the past century. Universal space is time invariant. There is no physical time in the universe, there is only motion. And we use clocks to measure duration. Let's say I'm moving this object from here to here. And now I watch my clock and I see, okay, this was 5 seconds. So duration, in physics, duration is time. Duration is the result of the measurement. But duration does not exist as a fourth dimension of space.
Yeah.
And what is the most impressive, and which is deeply linked to the culture of India, that we experience this space always as now.
Yeah. I have got funny thing in my mind. People are much more fascinated with the Einstein's theory because it explains about time dilation. So they use in movies, Hollywood movies, as we see
Yeah.
in Avengers, in Ant-Man. So
science
there are
fiction
science
movies.
fiction movie. Yeah, we can say. But to accept real physics, they must avoid it. But in the reality, time is something what different. Yeah, as explained by relativity, time is something what different. So that's why I say people should ignore that time as we have already been studied, been taught in our schools, in our college, in our universities. So we must accept something new so that we can explain entire physics this time.
In the quantum physics, we know for 100 years in quantum physics, this time is only a mathematical parameter to describe the motion of the particles. But somehow this idea that time has physical reality is so deeply rooted in the human mind that we cannot step out of it. But basically, Albert Einstein, this is a famous quote of Albert Einstein: past and future are stubborn, persistent illusion. Only the now exists. And then there's Erwin Schrödinger. The only time is now, and this now is eternity itself, something like this.
Yes.
Because what is the case? The case is that when you observe the object is moving in space, you experience this in the frame of linear time, which runs in the brain.
Yeah.
So the linear time, past, present, future, runs in the brain. And you in India, as a very deep spiritual nation, you have a lot of tradition that a human being can step out of the linear time.
Oh, well, I have a question once more
Yeah.
to you both.
Yeah.
Sorry to say, but it's just a different question.
Yeah.
We all know the Einstein's theory, and if I say the science fiction movies, they all are inspired by the Einstein's prediction, Hawking's prediction, such as to open a portal and enter in a new world. There's a time traveling. So, according to you both, does it really possible in real world?
It is not actually possible thing because it is science fiction part. So let it be
Does
fictionary
this
part.
really happen or not?
No, it is fiction part. So let it be fictionary part. Yeah.
We can only move in space. And duration of motion in space from A to B is time. We never move in time.
Okay.
Time is a tool of physics that is created by humans to make physics. But time has no physical reality.
Yeah.
And this travel, some physicists, they say you can travel in past, the others say no, you can't travel in past, you can travel only in the future. They don't understand that actually
They are denying.
actually
They are denying progress of physics. If they want to progress in physics, they must accept what
Accept
is the
reality.
reality. Yeah, what is the truth. If they do not, then they will not progress.
Sometimes I think where the human brain, where the scientists, where the professors, the research holders, got any difficulty
Yeah.
in physics equation,
They introduce new
turn
theory.
them, they turn them in a fairy tales.
Yeah, fairy
They
tales.
turn
They
them into
introduce
science
new theory.
fiction.
Yeah, They introduced new
Eh,
theory
that's
again.
that's something that is really impossible
Yeah,
to.
that's why I say if they want progress in physics, they must accept something real, which
Yeah.
as we have done in Bijective Physics Institute.
Acceptance is important.
Yeah, they must forget
Yeah,
about
accept reality, guys.
Yeah.
Beautiful case about this, because when the Webb telescope discovered 2 years ago or 3 years ago that there are 6 huge galaxies, they don't fit in the Big Bang cosmology. A few months later, article was published that actually the Big Bang didn't happen 13 million years, but 26.
Oh well.
So they doubled the time of the Big Bang, and this was published in a high-ranked journal in England to save the Big Bang, you know. But the Big Bang,
This is dogma.
actually, the Big Bang is not scientific theory.
It is religious.
Big Bang is religious dogma. Because you imagine what in the Stephen Hawking published an article with Hartman that universe has exploded from mathematical point. Mathematical point has no dimension, and something that is dimensionless cannot have attributes of energy.
Yes, of course.
So this explosion out of mathematical point and then inflation and all this has nothing to do with real physics. Because also the cosmological redshift, you know, is an empty term. Because we never measure Doppler effect in an expansion space. And what we observe is that the light that is coming from distant galaxies has a so-called tired light effect. It's losing some of the frequency, some of the energy, because out of the strong gravity. So I hope that in my lifetime the Big Bang theory will be recognized as something that belongs to the history of cosmology.
Yeah, of course. And this time, we must be ready for something new to accept. Yeah, like as gravity, we have explained about as a planet or an object diminishes the space energy density, and more things. And our article, I will show some page of the article to audience so that
Yeah.
they must believe on that what we have done, it is real. Like we have mathematical equations which explains everything correctly.
The original
The light
equations.
bending, everything, light bending part, the angle as Einstein predicted. Yeah, we have also the same thing. So
Okay.
Yeah.
Well, so just make a topic on Big Bang theory. So, what are your views and how our universe is originated when there was void?
then, to introduce this, so
Yeah.
we must need a fascinating theory. Yeah.
No, in a one line. How would you?
We published it 2 years ago an article, evidence-based cosmology, because my idea is that we have to build cosmology which is based on evidence, not on some
Yeah. Fascinating.
theoretical idea that sometime big in the big past everything has exploded. So these jets that are coming out of the
Black hole.
central galaxies,
Yeah.
central black holes. These central black holes are a rejuvenating system of the universe.
This is the key point.
So they are eating old matter, throwing out fresh energy.
Yeah, as I explained, this is the asymmetric
That is
flow.
the-
Yeah.
When anything comes to the planet, it ejects out or it regenerates energy into the universe again, right? As we
Yeah, this
release
waste energy
yeah,
is then the material for the new stars.
Yeah.
And this process never started. The idea that universe started is somehow is a bit childish.
what is everything?
I
Yeah,
lived 2 years in India.
yeah,
And once I was talking with a very sincere, very nice man. He was selling melonas. How you call it, melonas?
Yeah.
Watermelon.
Papaya, melon,
Papaya, yeah,
and
yeah,
stuff.
yeah.
And he used to say to me,
Okay.
Amrit, universe is not a melon,
Yeah.
you know,
Yes.
because before the Big Bang Theory, it was a stationary model. Nobody was asking how universe appeared because
Yeah.
the entire idea is not scientific, it's religious.
Yep.
We have to discover and to search how universe functions.
Yeah, this is the thing which I was saying. How universe behave, how universe works.
Yeah, of course. Whenever we see, whenever we see.
religion, you know.
Yes, yes, yes.
Okay. Let me complete, sir.
Yeah.
Let me complete.
So-
I know there are two legendary research holders, so please.
No. You may complete, yeah.
Well, whenever I see the religious theories and religious concepts about universe, these are just scripted lines.
Of
They've been
course.
put in the mind of the people.
Yeah, and that looks fascinating. That's
Yeah.
why people are not ignoring. But let me tell you one thing. What is everything? Real ether is everything. Yeah, it regenerates energy. It rejuvenates everything in the universe again. And this is what as Sorry sir, said this time, like we should focus on how the universe behaves, how the universe works. This is what we need. How the universe starts. This is not the main thing to grasp, to understand.
He wrote this idea of cyclic cosmology of Professor Penrose. So he said there was a Big Bang, now universe is expanding into infinity, and then the new Big Bang will happen. I mean, this is not serious, you know.
Yes. This is
These are just scripted lines. Just memorize it.
Fascinated line
Yeah.
to make people happy.
Yeah. We have to respect the basic principles of physics.
Yeah.
The basic principle, the number one of physics is the energy cannot be created and cannot be destroyed.
Yeah.
It
Yeah.
can be transformed into different types of energy.
Yeah.
So nothing in the universe ever was created and nothing ever will be destroyed.
Yeah. And for this consistent, our theory works well.
Only.
Yes.
Well, sir,
It's just a
Yeah.
I have one question more.
Yes, please.
I just want to ask. We all know energy mass relationship given by the Einstein.
Yeah.
E equals m square, the most famous equation. we all know.
Yes.
So, what do you think, and what are your views on
Well, let me
this?
tell you. This, credit goes to sir because Sorley sir has, explained very beautifully. I will
Yes,
show
sir.
you its mathematics, like how Sorley sir, presented its mathematics. It is extended part as he explained about it.
So, would you like to say or explain the energy mass relationship in one line, please, for the audience?
in two lines.
Two lines.
The crucial question is when we have a physical object in space, in what kind of relation is this physical object with the energy of the space? Because we know today space is not empty. Space is a type of energy.
Yeah.
So, we know that every system in physics has a tendency for a equal distribution of energy. So my idea was years ago that if there is a physical object here, must be that the density of space in the object is a bit less.
Yeah.
And then when I went deeper into the ether model, and when I discovered also this idea of Newton, that ether has different density, I was searching for this equation for 5 years. And then one day I said to my wife, listen, this is not my destiny. I will not find this formula because I knew it exists. And then I went to sleep I gave it up, and somehow I got this intuition in my head. The voice told me, you start with the Planck units, with the Planck energy density. This is the beginning, and the formula will come out.
Yeah.
So once in the middle of the night, I wake up and I start writing this formula.
And this is how things
And
work.
then
By sleeping, by having a good nap.
By having power
and
nap.
then I went in my bed,
I also would
and
like.
in the morning, said to my wife, I got a formula. Energy is mass
Equal squares of speed of
about
light.
and then
Energy density.
Oh,
plus energy density minus energy density in the center of
Which
the
is
physical
diminished.
object by the volume of the object.
Yeah, which has been diminished, that energy part. I will sort
And
of this.
I sent this formula to my good research fellow physicist from Italy, David Pistoletti,
Yeah.
and he wrote me back, it's a great idea.
Yeah.
It's a great idea. So then we developed this concept together. What is really elegant, that this equation is also valid for all relativistic phenomena. You just have to add Lorentz factor. Because when the proton is moving in the superfluid space with high velocity, the proton will interact with the energy of space and getting some energy of space inside. And
Yes.
this is called relativistic mass.
Yeah.
Relativistic mass and relativistic energy is the result of the interaction of the physical object with superfluid space. So this is somehow real physics, because what is now is still today in physics. Some physicists, they say relativistic mass depends on the observer. Relativistic mass has nothing to do with the observer.
Yeah. Of
You know,
course.
it's a pure practicality of interaction of the given physical object with the superfluid space.
yeah. So,
This is the real thing which we have. Yeah.
well,
Yeah.
we,
Yeah, of course.
sir, it's a really legendary talks with you. It's my honor. It's a pleasure to share a screen with you both, because it was really too much hard to discuss on physics, on physical laws with two research holders. But I did. Well, I really want to discuss more further, but we have lack of time, so we have to turn.
Good. This is yeah. Thank you for the invitation.
Yeah, yes, thank you.
And once we will have this online, then for the next,
Yeah, next part
Yeah.
we'll discuss more.
we can have an open line, so we can also invite some followers, some who will look the interview in India, so
Yeah.
we can have an open discussion
Yes, sir, of
Definitely.
with the
course.
public.
Well, sir, we both are teachers. We have many students, and we all are inspired. You inspires us all. So, would you
Thank you. man.
please say something for our students? That how to grow up and how to be attentive in studies.
They must accept Bijective Physics Institute, to be honest, because this
Yeah.
is real physics.
Yeah, of course, it is. So, how do you study?
My advice,
Yeah.
is never believe what they tell you.
Yeah.
Check yourself.
Yes,
You know,
sir, it's a legendary thought.
Yeah, what happened today, that whatever happened, people say, I will ask artificial intelligence.
No.
You know?
Yeah.
And if we will ask everything artificial intelligence, then we are done. We have our own intelligence and we have to use it.
Yes.
Well, fascinating insights from both of you. I really
Yes.
say from the bottom of the heart. And thanks for unpacking these ideas so clearly. So, thank you so much, Robot.